So let's see what we remember on number 2. What equation did they give you? Position, velocity, or acceleration? They gave you velocity. What do you want? Position. Is that a derivative or an antiderivative? Okay, so the first thing, even though it's multiple choice, we want to practice labeling. So we would put x of t equals the integral of v of t. Okay, now take the antiderivative. Okay, normal power rule on it. So if it's 3t squared, what's the antiderivative? You're going to add 1, then divide. So t cubed. And then the 3 in the front, when I divide it with the other 3, now it's gone. Okay, then 6t, what's the antiderivative of that? Plus c. Okay, read through the question. Find the point that they gave you for position. Okay, they gave you a point to help you find c. Okay, which order does it go in? Is it 0, 2, or 2, 0?
0, 2.
Yep, that's right. Okay, that's what they gave you right here. So 2 is the y value, and then t is like your x value. So don't be confused about the x being a 0. Remember, that's for position, that's a y value. So c automatically is 2. That means that x of t is t cubed plus 3t squared plus 2. Okay, then what does it ask you to find? Position at 1, which means I'm taking 1 and doing what with it? Plugging it in. So I'd find x of 1 equals 1 cubed plus 3 times 1 squared plus 2. What's that going to be equal to? 6, which is B. Did we do 5 yesterday? Or we didn't get to it? Okay. Number 5, I'm going to have to go to another sheet of paper because I write too big. But you, if you write small, can probably fit it on there. Okay, so it says a pendulum swings where the position of the pendulum is at a rate modeled by dx dt 2 sine t plus 1, measured in meters per second where time is in seconds. Okay, dx dt stands for the derivative of position with respect to time. That is the same as velocity. It's the exact same thing. It's written differently, but this means the derivative of position. So, maybe I can fit it on here. So, v of t is 2 sine t plus 1. V of t is 2 sine t plus 1. Okay, then it says at time 0, the pendulum is at position 5. Says it's to the right of the center. So that's why I would let the position equal a positive 5. What if it had said it's 5 to the left? Negative 5. Very good. Then it says write an expression to model the position of the pendulum. Okay, how do I get to position from velocity? Derivative or antiderivative? Anti. Very good. So I would do x of t equals the integral of velocity. And now I'm going to do the integral of 2 sine t plus 1. Okay, remember for sine, you can do snow cone, bottom two are negative. If I'm at sine and I have to go up, where does that put me? Negative 2 cosine. Okay, so remember, the 2 stays in the front, but if that's a negative cosine, I'd write negative 2 cosine. Okay, then what's the antiderivative of plus 1? Plus 1x or 1t, right? Okay, plus what? C. And then what do we know about our point? 0, 5 has to be a solution. So find your C for me. So 5 needs to be the answer when you plug in 0. So 5 needs to be the answer when we plug in 0. Okay, 1 times 0 is 0, so that's going to cross out. Will cosine 0 also cross out? No. What is the cosine of 0? 1. So this is really 5 equals negative 2 times 1, which I'm not going to put, and then plus c. Which makes my c what when I solve? Will it be 3? Just combine them? 7. You have to add that 2 across, so my C is 7. Which means that my final equation, it says to write an expression to model the position, would be x of t equals negative 2 cosine t plus 7.
So that we could just cross it out.
You can, yeah. If you went right here and scratched that out and put a 7, that would be fine. Just make sure whatever you're doing that it's neat, so that on the AP test, so that when they're grading it, they'll know what you're doing. Okay, last one. Read through number 6. I want you to find an ordered pair. Okay, it says an evergreen nursery sells a certain shrub after 6 years of growth and shaping. The growth rate during those years is modeled by the differential equation dHdt equals t over 2 plus 2, where t is the time in years and h is the height in inches. The seedlings are 5 inches tall when they're planted at 0. Okay, what is my ordered pair? 0, 5. So I'm going to put h of 0 equals 5. Now, if this is labeled dh dt, that's a different notation for what? What is this really? H prime, right? You could just call it h prime of t. It's a different notation, but it's the exact same thing. So I'm going to rewrite down here h prime of t equals. Now, I'm going to do one other thing here. If this is a t over 2, is that the same as a half t? Okay, and I'm going to separate the coefficient from the variable so I can do power rule. Okay, so we want to find the height. I have h prime. What do I need to do? Antiderivative, so I'd put h of t equals the integral of h prime of t. And now I'm going to do it. So do your rule, normal power rule, you'll have a plus c. Okay, what is the antiderivative of a half t? T will go to be what power? 2. And then I have to do a half divided by 2. A fourth. Okay, so a fourth t squared plus antiderivative of 2 is 2t plus c. And then we know that at h of 0, it should equal 5. So that means that 5 is the answer when I plug in 0. Well then, these guys are both gone. A fourth of 0 and 2 times 0 are gone, then c is 5. So we'll just cross out here, plug in a 5, and you're good to go. Now, one more time, I think I said this yesterday, but in case I didn't. If you scribble the C all the way out there, okay, you want to cross it out neatly, because a lot of times they'll give you a point for remembering to put a plus C. And so if you scratch the heck out of it to where it's gone and the guy doesn't see it, then he might be extra. So that's why you want to just neatly cross it out, put the number in, and you're fine. Or rewrite it is also good. Okay, part B, how tall are the shrubs when they're sold? When are they sold? Read it. After 6 years is correct. So I would need to say, okay, this is when they're planted till forever. So if they're sold at 6 years, then I would find h of 6. So it'll be a fourth 6 squared, 2 times 6 plus 5. Okay, I'm going to give you about 30 seconds to do the algebra on that. Okay, you should be able to work this one out to like a normal whole number. Okay, Yoel, are we a little distracted? Yeah? Little? Good, thank you. So 6 squared is how many? 36. Can 36 divide by 4? Close? 9. Plus 2 times 6 is 12. Plus 5. So really 9 and 12 is 21, plus 5 more is 26 inches. Good? All right. And then if it's free response, would you even waste time doing that? No. No, you would leave it just like this, because if you accidentally put the wrong number, you're going to lose your point if you simplify it wrong. So if it was FRQ, this would have been perfect. right here. Okay? All right, so we have now finished yesterday's notes. We're going to today's notes. We're not going to do all of them, just because I want to have a little bit of time to look at your homework. So go on number 1. I want you to just write down the 2 points. We're not going to do number 1, but I want you to just practice writing the points or the ordered pairs that they gave you. Okay? So specifically, this last sentence, I want you to break it down into 2 ordered pairs. Yeah.
The one that we picked up today?
Uh-huh.
It's not the right one.
Oh, is this your homework? Oh, I'm a dodo, sorry. Those all look so confused. Okay, do it on your question, on your set. Yeah, you're right, my bad. Okay, so at time 1, what is the velocity? Is it 36? Why is it negative? Okay, good. Left. And then for my position, it says it's at 10 to the right. So what is my position at 1? Positive 10. Good. Okay, skip the rest of it. Go to number 2. Okay, 1 and 2 are similar enough that that's why we're skipping it. Okay, so come down to number 2. Particle moves along the x-axis so that at any time its acceleration is given by e to the t. At time 0, the velocity is 6, and the position is 16 units to the left of the origin. Write down your velocity and your position point, both of those 2 things. Okay, what is my velocity? 0, 6. What's my position? 0, what? Negative 16. Why negative? Because it's on the left. Okay? Alright, part A. Find the velocity. We have acceleration. We want velocity. Are we doing a derivative or an antiderivative? Okay, antiderivative. So I'll put the integral of acceleration equals. And then if it's e to the t, the derivative of e to the x is still e to the x. So the antiderivative of e to the x is still e to the x. Because remember, they're just backwards. So this would be e to the t plus c. Okay, then what's my initial condition? At 0, what's my velocity? 6. So 6 equals e to the 0 plus c. And then does e to the 0 cross out? To 1. Very good. So really, this means that 6 equals 1 plus c. Which means that c is what? 5. So then it would be v of t equals e to the t plus 5. Okay, part B, find the position of the particle. How do I find position if I have velocity? One more antiderivative. Very good. So the first thing that you would write is x of t equals the integral of v of t. And then now we're going to do it. So this is part B. Okay, so e to the t, what's the derivative of that? Still e to the t. What's the antiderivative of 5? 5x or 5t, and then plus c. And then what's my ordered pair for position? At 0, it should come out to be what? Negative 16. Very good. So e to the 0, 5 times 0, plus c. Okay, well 5 times 0 is 0, so I'm going to cross that out. But then remember that e to the 0 crosses out but leaves a 1 behind. So this is really negative 16 equals 1 plus c. Which means that c is what? negative 17. Very good. And then I'm going to rewrite my equation down here. Okay, well then my x of t equals e to the t plus 5t minus 17. Okay? Now, I think we did one of these yesterday, the towards or away from the origin. What two things do you have to plug into? Position and velocity. And then for speeding up and slowing down, what do you have to plug into? Acceleration and velocity. So find those two things for me, for both of those. And then this would be v of 1 and a of 1. And just be careful to what you're plugging into. Now, for every single one of those, you should be able to tell if it's going to be a positive or a negative number. Remember, that's what you're looking for, is if it comes out positive or if it comes out negative. You don't even really care about the number, just the sign. Yeah, but remember, e and e to the 1 are the same. So you can put the 1 if you want to, though. Doesn't matter. E to the 1 plus 5 e to the 1. Okay, so decimal approximation of e is like about 2.5. Okay, it's not exact, but close enough. Okay, so that's 2.5 plus 5. That's like 7.5. Then minus 17. How does it come out? Positive or negative? Negative. Remember, I don't care about the number, just the sign. If it's a negative value, which side of the origin is your particle on? Okay, it's on the left side. And then I need to plug into velocity to know which direction it's traveling. So if it's e plus 5, that's going to come out what? Positive. E is positive, 5 is positive, add them together, it's going to stay positive. Which means that my particle is traveling to the right. Draw the picture if you need to. If I'm on the left and I'm traveling right, am I going towards or away? Towards. Okay, and if you needed the picture, it would look like this. Here's 0. I'm on the left, but I'm traveling right. That would be a towards. Okay? Now for part D, I already know my v of 1 is positive because I already figured it out. My a of 1 is e to the 1. E is positive, so that means that they are both positive. Speeding up or slowing down. Good. Normally the way that the AP test phrases that is that they would say the speed is increasing. Okay, so that's the same thing. And then I would say because a of 1 and v of 1 have the same sign. But remember, speeding up and speed is increasing, those are the same. Okay? All right, turn the page, please. Okay, we are going to skip the next question because you need to have a calculator to do it. And we are going to jump to the question number 4. Okay, it says a particle moves along the x-axis so that its velocity is given by, okay, boom. Then it says the position of the particle at time e is x of e equals 5. So look, they even gave it to us in the form that we wanted in. Part A, when is the particle at rest? How do you find that? Set it equal to 0. Very good. Not plug in 0, set it equal to 0. So I'm going to let 0 equal 2 over t minus 1. 2 over t minus 1. How are we going to solve it? Okay, plus the 1 across. Okay, good. That's a good start. So now I have 1 equals 2 over t. From here, I'm going to cross multiply. What is 1 the same as if it was a fraction? 1 over 1. And then I'm going to cross multiply. Okay? So, 1 times t is t. 1 times 2 is 2. Now, some people in second period were like, can't you just tell that over 2? Yes, But if they give a point for you setting this equal to 0, you would not get it if you just said, oh, it's 2. You have to write down, I'm setting it equal to 2, and then, or to 0, and then you can jump to here. But that's where you want to be careful about doing too much in your head. If you're setting it equal, set it equal, then do the solving in your head. But you have to write it on your paper, okay? So 2 seconds, that's my critical number. Okay, part B, set up your number line. I want to know when the particle is traveling to the left. Well, then I need to do a sign chart. So this is v of t. This is x of t. What is a number smaller than 2 that I could plug in? Okay, 1. Now, a lot of times people will pick 0, but what does it say right here? Greater than 0. Can I pick 0? No. Now, think about why. Why could I not plug in 0 to this? Because t is where? On the bottom. So it makes sense that they're saying don't pick 0 or you get it divided by 0. So we're going to pick 1. Okay, so I'd have 2 over 1 minus 1. Well, that's really just 2 minus 1, which is what? Positive 1. Okay, now pick a number that's bigger than 2. Say we pick 3. So this was v of 1. Now let's find v of 3. So I'd have 2 over 3 minus 1. Okay, well, 2/3 is smaller than 1, so if I take away 1, is it going to be positive or negative? It'd be negative. Okay, that means that my particle's position was increasing then decreasing. We want it traveling to the left. So which interval do we want? 0 to 2 or 2 to infinity? Because v of t less than 0. Okay, part C, write an expression for acceleration. Okay, acceleration is the what of velocity? The antiderivative? No, the what? Normal derivative. So I'd put acceleration equals v prime of t. Now, when you see the 2 over t, it almost looks like a quotient rule. We're going to do a rewrite on it because we don't want to do quotient rule unless we have to. So I'm going to rewrite v of t equals 2t to the minus 1. Minus 1. Remember, you want it written as a power when you're taking a derivative. Okay, so now do your rules. You're going to take the negative 1, times it down. What's negative 1 times 2 in the front? Negative 2. What's the new power on t when I take away 1 more? Negative 2 as well. What about the derivative of a constant minus 1? Derivative would be 0. So then really this is negative 2 over t squared. Negative 2 over t squared. Okay, part D, is the particle speeding up or slowing down at 1? Speeding up and slowing down, I plug into what? X. Okay, I plug it in for the x value, but which two functions? Position, velocity, or acceleration? Acceleration and velocity. Remember, you need both? So remember, for speed, you have to plug into both. So let's do acceleration first. I'd have negative 2 on top, and then over 1 squared. How does that come out? Don't care about the number, just positive or negative. That'll be negative. Okay, now let's do velocity. I'm going to go back to the original version, this one up here, because I don't want to have to plug into that. So it'd be 2 over 1, and then minus 1. Okay, well 2 over 1 is really 2. 2 minus 1 is positive 1, yes. So my acceleration was negative, my velocity was positive. Am I speeding up or slowing down? Slowing down because they're opposites. So I'm going to put speed is decreasing because A of 1 and V of 1 have opposite signs. Okay? Okay, last two parts. Part C, I want the position. Position, I'm going to have to do what? How will I get to position if they gave me velocity? Antiderivative. So I'll do x of t equals the integral of velocity. Now, I'm going to do another rewrite on my antiderivative. I want you to look at it first. Think about, if you can think about what I might want to rewrite. Would I want to do power rule on this? Think about what would happen if I add 1 to the power on velocity. I'd get what? 0. And when I divide by 0, it doesn't work. What rule am I going to have to use? Do you remember? Natural log. Yes. So this is how I'm going to rewrite it. Look. If it's 2 over t, that's the same as 2 times 1 over t. And then hopefully you'll recognize your rule. 2 times 1 over t, and then minus 1. And then when you see that 1 over t, anytime t is on the bottom, that's going to be an ln when you do your antiderivative. Now, the 2 is just going to sit in the front. So it'll be 2, I'm going to write it down here. 2 ln t. What's the antiderivative of negative 1? Negative 1t, and then plus c. Okay, then what was our ordered pair that they gave us at the beginning? That x of e is 5. So that means that 5 is the answer when I plug in e. Okay, solve for your c for me, please. So I have 5 is the answer, equal to 2 ln e minus e plus c. Can I do this? No. Why can you not do that? Because e is in an ln. What happens to e and ln here? That's the same as what? ln of e is 1. Or you can think about they cancel out. That's fine. Okay, these guys cross out with each other. So I have 5 equals 2 minus e plus c. So do not cancel the e and the ln and the other e. They can't go together like that. Okay, then from there I need to minus the 2 across. What will happen to my 5? It'll be a 3 equals negative e plus c. Then how will I get c by itself for my last step? Take my e, whoop, add it across. So it'll be 3 plus e. Kind of a weird constant, but it's fine. Okay, and so then let's write our x of t. So it'd be x of t equals 2 ln t minus t plus 3 plus e. And that's my constant there at the end. Now, quick question. If I drop the absolute value bars, does it matter if it's time on the inside? No, because what did it tell me about time? That it's always what? Greater than 0. So if I take those bars off, nobody really cares. You're not going to miss them because time can't be negative anyway. Okay, last part, part F. Is the particle moving towards or away from the origin at time e? What 2 things am I plugging into? The position at e and the velocity at e. Okay, so plug into those 2 things. Draw a picture if you have to. And then we'll be done. We'll work on your homework for the last 20 minutes or so. Now remember, you won't be able to get the exact number, but you should be able to get about if it's positive or negative. Okay, for my top one, what happens with ln and e? Okay, so really that's just a 2. Then I have a minus e here and a plus e here. Can those cross out? Yes, so these 2 are both gone. So then really it's just 2 plus 3, which is 5, which is greater than 0. So my particle is on the right side.
It's already given to you, kids.
Oh, they did already give us. Okay, yeah. So what he pointed out is they gave us x of e is 5. That's true. Good point. Okay, and then for v of e, think about, e is about what we said? A little bit bigger than 2, right? So if I take 2 and I divide it by something that's bigger than 2, will it be a decimal that's bigger than 1 or smaller than 1? Smaller. And then if I minus 1 from something smaller than 1, how's it going to come out? Negative. Which means which way is it traveling? Traveling to the left. So if it's on the right side and it's traveling to the left, that means it's going towards. Okay? Alright, what I'd like for you to do is get out homework 1 and homework 2. They're due tomorrow. If you turn in homework 2 on Monday, I'll probably not count off. Okay, but homework 1 I will. And I want you, the last 20 minutes, if you have questions, let's do some problems. Okay, you've had it now at least for a couple of days. Oh yeah, go ahead. Okay, to where hopefully you know what we don't know how to do.
Mr. Can I see the notes from this? I wasn't
Sure.
here.
Yeah. This one. Yeah? Yes, ma'am.
Can you show us how we find maximum height and like hidden water?
Sure. So like number 2 or number 3? Okay. Look at number look at number 2. Okay, it says a swimmer dives into a lake from an initial height of 80 feet with an initial velocity of 64. Okay, acceleration on Earth is negative 32. If it, that's in feet per second squared. If it was in meters, it'd be negative 9.81. So if you remember that number, it's just because it's in a different metric system. Okay, so it says in part A, write an expression to model the velocity and the height of the diver. How will I get to velocity? Antiderivative, good. So I'm going to do the integral of acceleration. And if acceleration is just negative 32, what's the antiderivative of that? Plus c. Very good. Now go back to the question. What point did they give us for velocity? V of 0 is 64. So 64 is the answer when I plug in 0. So c is automatically 64. So I'm going to rewrite my velocity over here. Negative 32t plus 64. Okay, done. Part B, or actually same part, it also asked me to find his height. So height is going to be one more antiderivative. This time it's the antiderivative of velocity. So do your power rule on negative 32t. What will that come out to be? Yeah, plus. Okay, c, and now can we just look, what's our initial height? So is it okay if I just put the c and then cross it out to an 80? Are we good with that? Okay, because we know it's going to be 80 because the time is 0. Okay, so part C. When is the diver at his maximum height? Okay, this is where you have to think about what's a maximum. It's when the derivative changes which direction? Positive to negative. So I want to do a first derivative test, and then I want to find the relative maximum. I want to do a first derivative test and find the relative maximum. Now, question, normally I have to take the derivative. Do I have to take the derivative if I already know velocity? No, so I'm just going to set that equal to 0. So I'd have 0 equals, what can I factor out of negative 32t plus 64? Negative 32. That leaves me with t minus 2 left over, which means what's my critical number? 2. Let's set up our line chart. 2 is my critical number, and remember, for a max, I'm hoping to see a plus and then a minus, right? Otherwise, it wouldn't be a max. Okay, so if I plug in 0, what's 0 minus 2? negative, but then I had a negative in the front, so it's positive. Okay, then I plug in 3. 3 minus 2 is positive, but that negative 32 in the front is going to switch it to a negative. So then it goes up, then down. So, when is the diver at a max height? What would I say? 2 seconds. Okay, now, then it says, how high is he? How would I find that? I know it happens at 2. Where would I have to go back and plug that in? Into h of t, very good. So you would find h of 2. You see the difference? So when does he hit his peak? At 2 seconds. How high is he? I have to go back and plug in 2. Okay, and I'd be plugging into this one right here. Now remember, this is an FRQ, so you don't have to figure it out. You just have to write it down, plugged in, and that's good enough. Okay, so your time is 2 seconds, your height is whatever that comes out to be. Okay, part D. When does the diver hit the water? What is his speed at that time? If he hits the water, how high will he be? 0. Very good. So if I want him to be on the water, think about this is him. He's on, I don't know, some happy little cliff. Okay, when he jumps off, whee! When he gets here, that's the x-axis, right? So you want his height to equal 0. So I'm going to set h of t equal to 0, and then I'm going to solve. Now notice I'm not plugging in 0. I want the y value to be 0. So if this is quadratic, you're going to have to factor to do that. What can all of those numbers divide by? Negative 16, right? So then that'd be a t squared. That'd turn in 64 divided by 16 is 4. But it'd be a negative 4, because I divided by a negative. And then my 80 would turn into a minus 5. What will multiply to negative 5 subtract to minus 4? Yes, t minus 5 and t plus 1. Which means what are my 2 times that he could have hit the water? 5 or... Now, does negative 1 make sense? No, but remember, you're using a parabola, and how many times would this parabola hit the x-axis? Twice. But I don't want this one, right? Because that's not part of my model. I want this one. So it'd be t equals 5 seconds. Then it says, what is his speed at that time? So what do I need to do with 5? Do I plug it into velocity or position or acceleration? Velocity. Now, what's the difference between speed and velocity? Yes. Okay, speed, you just have to turn it positive. So remember that for 5, I'm going to find the velocity at 5, but then I'm going to turn the answer positive. So remember that speed is not allowed to be negative. So whatever answer you get, you're going to have to put it in absolute value bars or turn it to a positive. So v of 5 is here. Negative 32 times 5 plus 64. And then since I don't want to figure out what it is, boom. Okay, you're done. Now, obviously, if you had a calculator, it wouldn't be that hard. But you do negative 32 times 5, add 64. Now, think about, why do I know it's going to come out negative? Which way is the diver going at that point of the graph? He's traveling down. So his velocity comes out negative, but speed is always positive. Okay? Anything else? Do you want to do the calculator practice?
Yes.
Yeah? Number 5, by the way, if they give you position, are you going to do an antiderivative? No, this is only going to be derivatives. So if you want to put, this question is only going to have derivatives in it. Or I'll put no antiderivatives. Okay? Alright, number 6. You have acceleration, you want an expression for velocity. How do you find velocity if you have acceleration? Thank you. Okay, so I'll do v of t equals Integral of acceleration. What's the antiderivative of cosine t? Sine t plus c. Then what does it tell me about my velocity right here? At time 0, the velocity is what? 2. So 2 is the answer when I plug in time 0. Well, then c has to be what? What's sine of 0? Cosine of 0 is 1. What's sine of 0? 0. So that means easy, c is 2. So v of t equals sine t plus 2. Okay, part B, this is where your calculator comes in, is it says to find v of 3 and a of 3. Now, the reason you can't plug in 3 by hand is because it's not one of your reference angles. Okay? So, you would take your calculator, okay, and plug in those two numbers. If you don't have one, I'll do it up here. Okay, but you would do v of 3 would be the sine of 3 plus 2. Okay, it comes out to be 2.1411. Write that down. 2.1411. That was for v of 2. Okay, then for a of 2, I'm going to plug back into the original. What was my original function? Huh? Oh, I did mean 3. Thank you. Okay, yeah, I'm going to plug into a, which is here. So I need to find the cosine of 3. So let's find that. Cosine 3 comes out to be negative 0.9899. Negative 0.9899. Okay, is the particle speed increasing or decreasing? Which would I pick? Decreasing. Okay, part C, find an expression for the position at any time. Position at any time. What would I do for position? Antiderivative again. So, integral of velocity. What's the antiderivative of sine t? What's the antiderivative of 2? 2t plus c. And then it says the position is 5 units to the right of the origin. That means that x of 0 is 5. So 5 is the answer when I plug in 0. 2 times 0 will cross out, but what's cosine 0? 1. So it crosses out, but it crosses out to a minus 1. So then you have 5 equals negative 1 plus c, which means that c is close. You have to add the 1 across. So 6. So your x of t would be negative cosine t plus 2t plus 6. Okay? We don't really have time to do the last one, but I just want to remind you, when you do a graph of v of t, how will you know when the particle changes direction? What will it have to do in the graph? It has to pass through the x-axis. Pass through x-axis. Okay, and then how will you know when it's traveling to the left? Where will it be in the graph? It will be below. And then what about if you want it traveling to the right? It would have to be above. Okay? So you have s of t, you're going to have to find the derivative, and then graph it to answer those last couple questions. I'll be here after school till 5 if you need help, okay?
What question is this for? Is that 3?
That was... Hey, how are you? This was actually, we finished the notes.
Oh, that was a note?
Yes, so we finished that. I think you came in for that part. Wasn't that like right where you'd come in late or something?
No, I got here when you were doing this.
Okay, this was the end of the notes
Okay.
for Tuesday. We just didn't get to it, Carl.
All right, bye.
Okay. Yeah. Okay, do I get a copy? Yeah. Okay, perfect. Yeah, he's asked to go to Mr. Rodriguez and he's and he told me all of that. Oh, I got you. Okay. Okay. All this learning going on, right? Yes, ma'am. Just because I wanted to change something. On the AP test.
I've done the same thing with, not that same thing, but something similar.
Yep.
I'm always for.
Yeah, and you found your max where it changes sign. Yep, that's right.
Are you gonna drop? I thought you were dropping it.
Sure.
I was gonna ask.
You say you're gonna ask to drop?
Well, okay, I have a question about.
You already missed the deadline. You can't even drop.
No, I asked, and she said to ask you about it because I have a question about the AP exam.
Oh, okay, then hang on.
Oh, I don't want to sit. No, not those. Not those.
I think they're pretty cute.
Oh, thank you.
So you do the outside function, the derivative of cosine, and then times by the derivative.
No, because I asked, is like, are there any classes that I could?
So what would the derivative
Like
of
math,
squared be?
like models or something like that, or like sociology. And I was like, are there really no other classifications? No.
Okay, did you ask to be an aide?
Huh?
Did you ask to be an aide?
I'm already teacher's aide. She's like, I can't give you any like no credit classes. Like that's kind of BS, but okay.
Can she just let you leave?
Sine of pi t
Or like rearrange it so you don't.
I really can't. All my classes are pretty much set, so I can't really like do anything about it.
And you'll have
No,
to write.
I don't.
the
I
derivative,
shouldn't.
you don't have
Like
to
my
solve
first
for
and second
anything
period,
with it.
it's just like a class that I took. It's the teaching internship.
Was that your only
Technically,
question?
I don't need it. Did you finish recording?
I forgot to push stop.
Nice.
Wow, nice.